Next up, we have Annie Minoff and Elah from Science Friday's new podcast, Undiscovered. Welcome on stage.
Hey guys.
Hi.
I'm Annie.
And I'm Elah, and we are the hosts of Undiscovered, which is a new podcast about the backstories of science from Science Friday.
And tonight we're going to talk to you about rocks that fall on us from space. Because this happens. Rocks fall on us from space every day, 100 tons of this space rock. And most of the time we don't even notice it. But very occasionally, one of those space rocks makes a truly spectacular entrance.
Warning, this is a bit loud, or very loud. Yes, cover your ears. Good.
Yeah.
It still makes me jump.
Yeah, so maybe some of you remember some of that footage from a few years ago. That was a space rock heavier than the Eiffel Tower coming through our atmosphere and exploding over Chelyabinsk, Russia.
Mm-hmm.
Yeah.
So why is this happening? Why are rocks falling on us from space? Well, these days, our solar system is a pretty tidy place. Orbits, planets going around in these almost circular orbits.
And because Elah does all of our art, the planets smile, obviously.
Yes.
Yeah.
Well, they're very happy about the order. However, this is our main problem area. We've got the Asteroid Belt, which is a bunch of ill-behaved rocks, never made it as planets, just kind of hanging around, causing trouble. Sometimes they crash into each other. Sometimes they fly out of the belt, crash into other planets, even our planet.
Yeah, and when this happens, when a space rock comes at us, our atmosphere does everything it can to stop that rock. So it'll grind it down, it'll burn it up, it'll deconstruct it in pretty spectacular fashion, like we saw it doing over Chelyabinsk, Russia. But if any piece of that space rock survives this very perilous journey and it hits the ground, then we call that rock a meteorite.
Right. And for a lot of people throughout history, this idea that sometimes rocks will fall out of the sky, kind of magically, wasn't too controversial. The ancient Egyptians knew about it. They had this fancy hieroglyph that meant metal from the sky, which was their symbol for iron.
Yeah, but for years, the top European scientific minds, they were basically total rock from the sky deniers. Yeah. And they could get very creative about coming up with alternative theories to explain this thing that people kept saying they were seeing.
Yeah, like somebody comes up to you and is like, hey, I saw a rock just like fall out of the sky. An expert might suggest that perhaps it was windy that day, right? Because like the wind can sometimes throw rocks up.
Yeah.
That happens.
Or maybe it got spat out of a volcano, because that happens.
Yes,
Yeah.
It's called a volcano bomb. That is not a meteorite.
No.
So for a long time, this is the mainstream scientific position in Europe, especially in the 18th century. Rocks do not just fall out of the sky.
But then this happens. So it's noon, 1803, the region of l'Aigle, France. Mayhap you are a peasant tending to your field of wheat. When lo, what do you see in the sky but a globe of fire?
A globe de feu.
A globe de feu.
Yeah.
And the globe de feu crosses over the sky and it explodes very loudly, dropping somewhere between 2,000 and 3,000 space rocks on your village. Yeah.
Yeah. So this, as you can imagine, is terrifying. You're doing the hoeing. Was that what the motion? Yeah, the hoeing.
I'm reaping the wheat.
Just wanted you to do that again. And suddenly there's this fireball, a bunch of rocks. People were scared. People thought they were going to die. They threw themselves to the ground. Terrified sheep didn't show up. That's fine. Sheep, just imagine very scared sheep huddled together for safety, and a shepherd who was known in the region to have denounced religion reconsidered.
Yeah. And so this basically clinches it. There are too many rocks now. There are too many witnesses to shut them up and bury this story. Rocks are falling on us from the sky.
Which which is great. It's not great if you're in Chelyabinsk, because that legit looks scary, but it's great for scientists, right? Like, imagine space is every once in a while just chucking little pieces of itself at us for closer inspection. Awesome. If you can find these rocks. In this picture, there are 2 meteorites, and to the untrained eye, it's pretty hard to tell which ones we're telling you right now.
Yeah, so the question is, how do you find the precious little bit of space amongst all of the kind of generic Earth rocks that I'm sure are very interesting in their own right, but whatever. So that is what we are going to learn tonight. We are going to learn to pick out the space rock. We're going to play a game with all 1,000 of you? 1,000 for prizes.
Yes,
Yeah.
Concept's pretty simple. Spot the meteorite, get the prizes. And to help you learn how to spot that meteorite, we have an expert. I'm going to move over here to make room for her. A meteorite-obsessed cosmochemist. Please welcome to the stage Dr. Morgan Martinez. Hey.
Hey, Morgan. Thank you so much for coming.
Thank you.
So you have seen a few meteorites in your day, meteorites from the moon, from Mars, regular asteroids, but you've also gone out into the field to collect these things as well. So, and actually, to be very specific, you've gone to one of the hardest places in the world to get to, one of the most uncomfortable, the coldest. I'm talking about the interior of Antarctica. Yeah.
It's true.
So,
It's quite cold.
and that is you. So our first question is, why Antarctica? Our understanding is these rocks fall in more convenient places. Why go all the way out there?
Yeah, so the short answer to that is that yes, meteorites do land all over the Earth, but there are a couple of reasons why Antarctica is a really great place, not so much to look for them, so much as to have meteorites be found in. And so the reasons for this have to do with the Antarctic Treaty that protects operations that happen on the continent for
Yay,
not-for-profit
Treaty.
purposes, which means money doesn't have to exchange hands directly in exchange for these extraterrestrial specimens. The weather there also, because it is so cold and dry, does a really great job of preserving the meteorites, which helps us make sure what we're actually measuring in these meteorites is primordial. Additionally, there are a couple concentration mechanisms in the glaciers of Antarctica that concentrate the meteorites in specific areas. So those are the areas we look for, and they have about 10-fold higher concentration than anywhere else that we find on Earth.
So the glaciers kind of just smush the meteorites in a nice convenient pile for you to pick up.
More or
nice.
less, more or less.
I simplify slightly. But like, so what's a good haul? Like if you're out there, you and your team for a full day, how many pieces of space is it possible to pick up?
I would say a good day would be, I mean, if you haven't found any for a few days, you're excited about one. I think the most we recovered in a day, or that we found and had to come back and recover, was 89.
89.
So to put that into a broader context, this is searching with myself and 7 teammates, and over an 8 to 10 hour workday, we may recover from 0 up to that max of 89, and in a 6-week season, recover a few hundred.
And if you're like walking around the Castro neighborhood, you
Just like 75 in a day
Yeah.
in Castro. Like,
I always have my eyes peeled for them, even in the city, but I haven't found one in San Francisco yet.
Okay, not.
Keep your eyes peeled.
Yeah. So we have these incredible photos from your trip to Antarctica. It's this very otherworldly kind of alien landscape. What is it like to be in a place like this?
Have you ever imagined living on Hoth?
Huh?
what?
Have you ever imagined living on Hoth?
I can't say that I have, but now that I see the similarity, yeah.
Yeah, so this view you could see, well, the last one in here a little bit as well.
I can go back. Ah.
Yeah.
Yeah, so you can see a little bit of the terrestrial rock around here. So we search on the South Pole side of the Transantarctic Mountains, but if we're standing on that side of the mountains looking towards the South Pole, it's nothing but ice, just this dense blue compacted ice for about 1,000 miles. And so that's one of the more like otherworldly experiences of being there, just looking out on a barren landscape with nothing but ice and knowing that you could walk 1,000 miles and see absolutely nothing else.
Which is like terrifying, cool.
All of that.
Okay.
All of that.
And they're like no penguins, right? Because I thought Antarctica was a penguin kind of hot spot.
Yeah, they're
just no animals, right?
They're like, no, we're not dealing with this. This is too much.
There are some penguins and seals and some other sea life around the edges of the continent, but where we're doing our field work in the Transantarctic Mountains, there's nothing. There have been some strains of yeast that were found a couple hundred miles away from here on some rocks, but yeah, that's
Strains of
it.
yeast.
Thriving.
Yeah, yeah.
All right.
I would love to check that out. So, I don't know what is happening in this photo. Because this doesn't look like standard issue. I mean, it doesn't look weather
Is this your
safe.
NSF standard issue, like meteorite hunting gear?
No, the NSF can take no blame for this, for better or for worse. Also, for better or for worse, it turns out prom in Antarctica is pretty poorly attended. So, I wanted to really do my due diligence, like understanding the weight of those sequins when, I'm carrying all my stuff on my back. Please know what a commitment to Antarctic prom I made. We don't have corsages, but, jerry cans, it's fine.
Yeah.
What is that flag?
This is just like for funsies. Yeah.
Yeah.
Okay.
Yeah.
All right. Well, for fun, speaking of fun, so we promised these fine folks a game, and it is a game of meteorite identification. We are calling it, with no shame, no apology, Meteorite. Or Meteorite. You know where I'm going? Or Meteorong.
Can we get like a waka waka sound out of this?
Why
too?
isn't it clapping? What is
Oh
this?
God, no! Get out of the way.
All right.
Yes.
So the idea of the game will be you spot it. We're going to show you a rock. You're going to tell us if it's from space, and you're going to need some tips, right? Unless some of you already know what you're doing.
Yeah.
No, we're going to teach you. Okay. So we've got 4 tips. First tip: look for something called a fusion crust. So Morgan, maybe you can tell us what a fusion crust is.
Yeah, fusion crust is where the surface of a meteorite will be melted and crystallized. The melting is caused by heat that builds up from friction as the meteorite is coming through the Earth's atmosphere. And so that's a great example of it. It's typically a dark brown or black, shiny actual crust, and it has a particular kind of patina on it that probably by the end of this, you guys will have tuned your eyes to.
Nice. So black, shiny surface.
Like a black peel.
Tip
Yeah.
number 2 is shapes. So what kind of shapes are typical of meteorites?
I think the rounded corners and edges are the quickest and easiest thing to look for. Like you can see very clearly how rounded the edges of this are, which makes sense when we think about, again, that heating on the surface of the meteorite as it's coming through the Earth's atmosphere, sort of melting and making that new surface.
Shaving off the pointy bits a
Yeah.
little bit? Okay.
All right. Okay, tip number 3. So we're calling it pitting, not the scientific name. Sometimes rocks look kind of like this. Why? What is happening in this photo?
Yeah, so those pits that you see on the surface of that, this is an iron meteorite, and the pits are called regmaglyphs. Or sometimes if you're struggling with all of those letters together, people just call them thumbprints. But those are caused by uneven surface heating while the meteorite's coming through the Earth's atmosphere. And you see it on some subtypes of meteorites in particular that have different compositions, where there are spherical inclusions that have different melting points, and so they heat more or less evenly than the matrix sort of gluing it together and making it a rock, and those will pop out. And then that heating and melting effect smooths them out to get the regmaglyphs in place.
Okay. So uneven heating. We do have a 4th tip. There it is. These rules aren't real. Meteorites can do whatever they want. They don't have to follow our rules, and that's kind of like one of the things about meteorite hunting.
But we're gonna start
easy on you guys.
Pretend they're real for now.
Are you guys ready to play?
Meteorite or meteorite? Okay.
Yeah. Okay. So first thing, if you are able, please stand up.
Actually do it.
If you are not able, it's going to be honor system, so you can still play along.
Ooh, that's a cool sound.
More like a
All right.
stomping. And
So we're going to show you a rock. If you think that that rock is from space, you're going to raise your hand. If you think that that rock is not from space, you're going to cross your arms.
so meteorite.
Meteor
Wrong.
Morgan's going to tell us what is what, and if you got it wrong, you're going to sit down. That's how we're going to do it. You're going to pack your knives and go.
And we really
all right.
hope you guys are bad at this because we don't have as
We don't
many
have that many
prizes.
prizes, so we hope this
Yeah.
is hard. Okay.
Okay, so
Let's-
rock number 1.
Yeah.
All right, so if you think it's a meteorite,
Or meteor wrong. Okay. Everyone's committed. You're done. Okay. Morgan, what is it? Meteorite or meteor wrong?
It is indeed a meteorite.
all right, so anyone who had an great, good. I was expecting that. Anyone who said meteor wrong sits down.
Yeah. Okay.
You guys figured it out.
I think
All
we're
right.
good. You guys are good. Let's keep moving.
Okay, rock number 2, meteorite or meteor
meteor
wrong?
wrong. No looking at your neighbors.
Final decision.
Okay.
Morgan, what is the verdict?
This one is also a meteorite. Good job spotting regmaglyphs.
Yeah. Classic thumbprints. Did you guys see that? Okay.
Still a lot of you standing, but we started easy.
Yeah. No, you guys are really disturbingly good. Okay. Rock number 3. Meteorite or meteor wrong?
Final answer.
Okay.
All right, Morgan.
This one is not a meteorite.
Ooh.
So, what's wrong with this one?
Yeah, because it looks, well, it does not look fine.
No, we're pretty good at this by now. But
Yeah, so this, there are a couple things about this that are kind of like the not real rules, and this is a thing that I'm still developing metrics around because it kind of is just an intuitive feeling after a while. But one very, very concrete thing is the large variability of color on the surface.
Yeah.
Showing distinct composition, like distinct components that are in it. No fusion crust, unless this was something that had gotten broken apart in the Earth's mantle, and then, I don't know, it would require a really, really crazy mechanism to create anything that looks even like this on Earth.
So pretty
It's a
much
piece
like-
of slag, is what it is. All right.
all right, rock number 3.
4.
4.
4.
Doesn't matter. Next rock.
Meteorite or meteor wrong? It's getting harder now.
Okay.
All right.
I think we have final decisions. Morgan, what is the verdict?
This one is a meteorite.
Ooh, this one always gets people. Interesting.
Yeah. I mean,
Wow.
this one's kind of different.
Yeah, so admittedly, the appearance of this one is very rare.
It's tricky.
Yeah, we don't see many meteorites that look like this. What would have had to have happened in order for the meteorite to arrive on the surface of the Earth and still look like this is remain in a single orientation as it was coming through the Earth's atmosphere. And so the evidence for that is these sort of melt lines coming around the edges of it, where you see where the surface actually melted but didn't flip around, otherwise you'd see melt lines in different directions.
All right. We still got a lot of
That was a
contenders,
tricky
though.
one.
Yeah, that was
Yeah.
tricky.
Way too many people.
All right. Rock number 5? I don't remember.
Doesn't matter. Next rock.
Sure.
Okay. Meteorite. Meteor wrong. I can't
Okay.
tell what you guys. Oh no.
Final
There's like a
answer, final
mix. There's
answer.
a mix.
Okay.
All right.
Also a meteorite.
Yeah. That's just like the one you just saw.
You thought it must be a trick, right? No, I get it. That makes sense.
Yeah.
So like same kind of deal as
Yeah, same reasoning on that in terms of the melt lines on a surface.
Although this one's from Mars. Yeah.
You know, if Carrie Corrigan says that, I believe her.
Okay.
I would need to take a chip off to confirm that for myself. But
All right.
I believe her.
Yeah.
Okay. Next
rock.
rock. I hope. Okay.
All right.
Oh, yeah, it's getting serious. We haven't even told you what the prizes are, but you're invested.
Okay, we're committed.
All right, final
Morgan?
answers.
This one is not a meteorite.
Did we call you? Oh no, there's still so many. Some of you are really good at this.
All
yeah,
right.
you can see on this one all of the bubbles inside it, the bubbles of gas that would have been trapped as this was crystallizing. So it would have been volcanic in how it was made, which is a thing that can exist in other parts of the universe. But we do not have basaltic meteorites on the Earth that look like this.
No bubbles
No
in
bubbles.
our standard meteorite.
Not like that.
I think we're gonna do the next one's like rapid fire because
Okay.
we gotta eliminate you guys. So next one.
All right, next one.
All right.
Meteorite, meteor wrong.
Okay.
Can't tell. All right, Morgan.
This one is a meteorite.
Yeah.
So this one's a little
It gets
tricky
harder.
because it has it's clearly been weathered a little bit. So you can see the fusion crust all on this bottom right-hand corner, but where it's broken off on the top and the middle portions up there would have happened from weathering just while it was on the Earth's surface from humidity in the air.
It's a little busted up, but it's still a meteorite.
correct.
Yeah, so no, I get it. You're looking for rounded shapes, but when they break
Yeah.
and get weathered.
Next rock.
All right. Is anyone even standing?
Yeah, no, we got
Whoa, there's like 3 of you? Oh my God.
it. All right.
4, 5. Okay.
Morgan?
This one is also not a meteorite.
Ooh.
Wait, is anyone standing?
Oh my God! I think we have a winner. Wait. Balcony.
We have
Balcony.
1 winner? 2 winners.
Okay, we got 2 of you. Oh, it's a face-off.
All right. I feel like we should give prizes to everyone who's still
You
standing.
guys are gonna get like mad prizes. Don't worry. Okay.
Really?
Yeah.
Are we? Okay, we're gonna go down to the final one. All right. Okay.
Oh, balcony.
Balcony 2. Can't
right.
see you. We trust you though. Morgan, what's the? Wait, make your decision.
Yeah. Balcony person. You
People against-
decided. Okay.
This one is also not a meteorite. I think this is a sedimentary rock with a whole lot of iron oxide.
I see someone standing.
1.
One.
Balcony person's still there. All right. One more. We got 1 more rock.
Down to 1 champion. All right. Final rock. Whoa. I don't know. I do see.
Votes cast?
See you.
Is that crossed arms? Or are you just like?
That's
Yeah, no, they're
that's
crossed.
a meteor wrong. Okay, I don't know. Balcony person, what are you? Okay.
The balcony wins it. That is definitely a meteorite.
Well done.
All right. You guys are awesome. And actually, the prizes are these meteorite hunting stickers. We have quite a few of them.
They're really nice.
It's not a trip to Antarctica.
They're no foam bricks.
So you know what, honor system, if you were like down to the last, let's say the last 3, we're gonna have people at the back of this auditorium wearing Undiscovered
Wait.
and Science Friday shirts at the end of the show. So pick up a sticker or 2.
Last 3 people or last 3 rocks?
Last 3 rocks. Last 3 rocks.
We just trust you. Just take a
Last
sticker.
5 rocks. We're generous. All right, thank you guys so much for playing
Thanks for
along. We
playing.
appreciate you.